All right, 11.6 is permutations and combinations. Basically, it's a way of counting how many different scenarios something happens. So how many groups of 3 can we form in the classroom, or how many different sandwiches could you make, or how many different, shaking the dice, how many different outcomes would there be? So 11.6 is the counting part of it. 11.7 we'll just take it the next step further, and it'll be the probability. So if you have 100 different types of sandwich, what's the probability that you choose an Italian 12-inch on wheat? Then you could say 1 out of 100 if that's one of the possibilities. So 11.6 is more the counting part. And fundamental counting principle is when you've got, let's say we've got a spinner, we've got red, yellow, green, and blue spinner, and we spin it. And then we also have a die that has 6 different possibilities. How many different outcomes could you get when you spin a spinner and then shake a die? Well, you can do red 1, red 2, red 3, all the way down to red 6. Then you could do yellow 1, yellow 2, all the way down to yellow 6, green 1 down to green 6, and then blue 1 down to blue 6. So you could literally list them all out, 4 by 6, so there's 24 different outcomes. What's the easiest way to count how many outcomes we have if we have 4 possibilities here and 6 possibilities there? You just multiply them together. So that is the fundamental counting principle. If something has to happen like consecutively, there's 4 possibilities here, 6 there, you multiply them. And it also works when we do probability in 11.7. So what's the probability that you get a heads and then tails and then tails? Well, the probability of flipping a heads is 1/2. The probability of flipping tails is 1/2. What's the probability of getting tails? Well, that's 1/2. If all 3 of those have to happen, you also multiply them and you get 1 out of 8. So that's also the fundamental counting principle. It works with probability, which we're not talking about in 11.6. So multiply them. So I talked about sandwiches. If I have, what's the best sandwich place? It used to just be Subway. I remember when Subway came around for the first time. It was cutting edge, innovative. It's fast food that wasn't a cheeseburger. Now there's all sorts of different kinds. What's the best thing? Is Subway still the best?
Herbert's and Gerbert's.
Herbert's and Gerbert's? Okay, let's get finalists. We got Subway, we've got Herbert's and Gerbert's, Jimmy John's, and then give me one more.
Firehouse Subs.
Firehouse Subs?
I saw it on TV one time. It's a chain.
How about Jersey Mike's?
That works now.
At least I've been there. Okay, raise your hand. Who says Subway's the best? Ooh, 4. Herbert's and Gerbert's. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go 9. Jimmy John's. Unexpectedly only 2. And Jersey Mike's? Jersey Mike's gets shut out. What's the best sandwich place?
Where I work, Subway.
You think it's the best?
Well, I have to.
You have
my
to.
job.
It's your contractual obligation to say that the best sandwiches?
Exactly.
Fresh bread? Well, they came in second place. Apparently, in the scientific poll, Herbert's and Gerbert's is significantly better than Subway. And Jersey Mike's should pretty much close their franchise. All right, Herbert's and Gerbert's. How many different types of breads are there?
I think just 2.
Only 2. They just stick to what right. It's white and wheat then?
I think so.
All right, so then we've got meats.
I don't think they do build your own there.
Well, that doesn't work in my little game. We have to modify my game. We got meat. We've got beef. We've got ham. We've got turkey. Chicken. I ran over a squirrel last night. Put that on the menu. It lived. It just happened to be doing a cartwheel when I looked at it in the rearview mirror. It was just doing tricks. I really didn't double tire it.
Killed the one and only gymnast squirrel.
Yeah, it was fine. It walked away. And then cheese, we've got American, we've got cheddar, and this is a long way to make a point. We already know what the outcome is. Pepper Jack. How many different sandwiches at Herbert's and Gerbert's, even though this isn't what they do here? So we've got 2, 1, 2, 3, 4, 5, and times 4. There are 40 different sandwiches, because you multiply them. Make sense? That was about 3 minutes to make a point that you already know. Okay. Let's talk about permutations versus combinations. So permutation, I'm not even going to give you the definition of it, and we'll go combination. So combination, theorem, focus please. Combination would be like 7 choose 3. That is 7 combination 3. That's on your calculator. Permutation is also on there, but I never use the permutation button. So for permutation, order matters, and that's very important. I'm going to put an exclamation point. In combination, order does not matter. Okay, so that's the difference. So how many students are in the class? 2, 4, 6, 8, 10, 12, 14, 16, 17. We have 17 students. Let's say I want to make, of those 17 students, we're going to make groups of 4. Okay, does it matter what order within that group of 4 you're chosen? Does the order matter, or is it just a group of 4? It's just a group. Okay, since it's just a group and the order does not matter, that would be a combination. So it would be 17 choose 4. How many groups of 4 can we choose with 17 students? Your calculator tells how many groups of 4 we can choose. I see there are those. Okay, so that's an example of a combination. The order does not matter. A permutation. Let's say I've got a license plate. And the license plate, we'll say 3 letters and then 3 numbers. My first car ever was a beautiful 1983 silver Subaru station wagon, and its license plate is MKZ889. It's a true story. I don't know what my license plate is right now, but I know my 1983 silver Subaru.
I was going to say, thanks for letting us know if you ever commit a crime.
Yeah, it was a 5-speed stick, and it took about 20 seconds to get up to the speed limit. It just had no get up and go. Anyways, does the order matter? Is MKZ889 the same as MZK988? Are those different license plates? They are. So the order in which they occur does matter. So this would be a permutation. How many different license plates do we have with 3 letters and 3 numbers? Well, how many letters in the alphabet? 26, and then 26, and then 26, and the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10, 10, and 10. We multiply all of those together, and that's how many different license plates we have with that scenario. If one condition was the letters cannot repeat themselves, how many letters do I have for my first spot? 26. How about 25 and then 24? Very good. And numbers can't repeat themselves, so it'd be 10, 9, and 8. You multiply all those, and that's how many license plates where you can't duplicate the letters or the numbers. Okay, permutation, kind of what I do is I put these boxes and I literally just figure them all out and multiply them together. order matters for a permutation. Order does not matter for a combination. Okay, if the 17 students in here, I picked a gold, silver, and bronze. How many different gold, silver, and bronze awards could I give out? Is that 17 choose 3, or is that a permutation? Does the order matter?
Yes.
Yeah, if I pick you first and you get gold, that's different than picking you second, getting silver. So it would be 17 times 16 times 15. That's how many different ways we can get gold, silver, bronze in here, because the order matters. Another combination. Anybody still play cards? Raise your hand if you've played cards in the last 2 months. Good. Everyone should play cards. It's good mental, it's good camaraderie, it's good math, a lot of probability.
I don't know so much about camaraderie.
What? Does it actually create friction?
Well, last
Do you
time
play for money, Connor?
No. Last time we had a poker night, we just decided for goofs and laughs to go all in, and then my friend dropped a full house, and
And he's no longer your friend?
no, he's no longer somebody else's friend.
All right, so let's say we're playing old school poker where you get 5 cards rather than Hold'em where you all hold them. How many different ways could you get a hand of 5 cards? Does the order matter? If you're picking up a hand of 5 cards, does it matter which order you get each card in?
Well, I mean, if you get a card, it's no longer a card you can get again.
But does the order matter?
Not really.
It doesn't matter. So if I want to know how many different card hands of 5, it would be 52 choose 5. That's how many different hands you could get if there's 5 cards. And that's a lot. Okay, order does not matter there, so it's just a combination.
8,960.
That's quite a few.
Isn't there like, every time you shuffle a deck of cards, it's never the same, because there's like a trillion different combinations or something?
What do you say?
Isn't there a thing that like, whenever you shuffle a deck of cards, it's never the same, because there's just that many combinations?
I don't know, but there's been a study. I actually was thinking about this morning or yesterday that if you shuffle more than 7 times, it's either 7 or 8, you are no longer mixing the deck up, and it's reached its maximum randomness if you shuffle beyond 7 times or 8 times.
There's a
Yeah,
limit to how random you can get.
depends how good a shuffler you are too.
The deck of cards have anything to do with the 50-second factorial?
50-second factorial? What is that? Is that a thing?
Yes.
I don't know about that.
Oh,
Yeah.
It's
Well-
the number of ways you can, like the number of random combinations of cards.
Oh, really?
Oh, yeah.
Yeah, because the first card's going to be 52 choices and then 50. Yeah,
That's
very
a
good.
big number. That's 8.1 to the 67th power.
Wow.
There's a very low chance you would ever be able to shuffle the cards into the correct order.
All right. So how many different? Let's say we're going sledding, and we've got a. Do you say sledding or sliding? I used to say sliding. We got a toboggan. We've got 4 seats in our toboggan. How many different ways, with 17 people in here, could we arrange those 4 seats? Is that a combination or permutation?
Permutation?
Do we agree? Does the order matter?
Yes.
It does matter, right? So that is a permutation. So you'd literally do 17, 16, 15, 14, and if there were 17 seats, it would literally just be 17 factorial. It would be 17, 16, 15, and multiply them all together. But if we had groups of 4, then it would be 17 choose 4. All right, I think I call that good. If you're watching this video still, I apologize. You could have stopped it like 3 minutes ago.